Welcome to the Drowsy Science Channel and hello, an area where inquisitive minds can congregate, unwind and acquire knowledge. You're in the right place if you think this sounds excellent. Let your body rest then. We're going to be studying galaxies tonight, so let your breathing slow and your mind wander. Not only our own, but also some of the universe's most intriguing galaxies. From massive spirals and silent dwarfs to broken relics that are still glowing from long-gone collisions. We will see infant galaxies burning at the extreme frontier of the known universe, black holes flashing like cosmic candles, and invisible halos of dark matter. Certain facts may seem odd or amazing. All of them are genuine, even though some may fade in subtly like the silence of a recollection. They are all silent echoes of the universe's grand and continuous drama. Please feel free to like and subscribe if you find that this voyage helps you relax. It also makes these films easier for others to find. When you're ready, release your thoughts into the world. Let's start by letting your breath fall like stars on a faraway planet. A galaxy is called a quasar if its black hole is brighter than any of its stars. Black holes become ravenous at the core of some galaxies. The material spirals inward, heating up and blazing brilliantly as they consume the gas and dust around them. A quasar is created when a black hole consumes matter at a high pace. Quasars are incredibly luminous, frequently outshining the entire galaxy in which they are located. Their light pierces cosmic time, and some can be seen from billions of light-years away. The heat and velocity of the infilling material provide the energy instead of the black hole itself. Gas disks surrounding the black hole can get as hot as millions of degrees. Particle jets shoot into the sky. Additionally, the galaxy briefly rises to the top of the universe's brightness rankings. Dark energy powers quasars, which are active galactic centers that shine brighter than 1,000,000,000,000 suns. The Sagittarius dwarf galaxy is currently being consumed by the Milky Way. We live in a slow-motion feast in our galaxy. The Milky Way's gravity is currently tearing apart the small, dim neighbor galaxy known as the Sagittarius dwarf spheroidal galaxy. It has already made multiple trips through our galaxy, losing more of its stars every time. These stars now form long streamers that resemble ribbons around the Milky Way, faint signs of the digestion of a galaxy. While not yet extinct, the Sagittarius dwarf is deteriorating due to being overextended and drawn in by unavoidable factors. Astronomers are learning more about the Milky Way's evolution thanks to its remnants, through the gradual accumulation of smaller galaxies, rather than all at once. Numerous earlier occurrences like this have led to what we see in the night sky. In that continuous process, the Sagittarius dwarf is merely another phase. Our galaxy is still changing now as a result of the things it attracts. Two extremely big black holes can be found in some galaxies. Central black holes in merging galaxies frequently do not merge immediately. They create a binary system instead. A slow spiral involving two extremely big black holes orbiting one another could take millions of years to settle. Although it is challenging to find these dual black holes, astronomers have discovered a few of them. Both black holes may occasionally be active and appear as distinct points of light. In others, we spot clues in the movement of surrounding stars, or in odd changes in the light that is released. The evolution of galaxies naturally includes these couples. They might eventually combine and spiral inward because of gravitational radiation, creating vibrations that reverberate across space-time. However, they remain concealed deep within the centers of merging galaxies, orbiting in silence until that time. They beat in the same chest like twin hearts, powerful, uncommon, and rife with unsolved questions. There are galaxies that contain only dark matter and no stars. There are galaxies in the vast silence of space that shine without any light, not even the faint glimmer of gas. No clusters, no starlight. They are real, nonetheless, and are kept together by things we cannot see, rather than by things we can. These are dark matter galaxies, composed almost completely of the enigmatic material that dominates the universe's apparent stuff. They were discovered by astronomers using gravity rather than light. These black galaxies exhibit acquired distortion, which displays their invisible mass by bending the light of farther-off objects behind them. Some were found by their subtle pull on nearby galaxies. Others just became visible due to motion patterns and ripples in the surrounding gas. How they formed is a mystery. They float through space like silent shadows, hidden islands of gravity with no light at all. But they may be failed galaxies or leftovers of others that have long since been wiped. Cosmic tides are tearing away the Milky Way. Even our galaxy is enmeshed in the current of more powerful forces, despite their apparent timeless and unchanging nature. The gravity of neighboring galaxies, particularly the enormous Andromeda galaxy that is traveling toward us across the cosmos, is gently but steadily pulling the Milky Way. Similar to the Moon's pull on Earth's oceans, but on a cosmic scale, these forces are known as tidal forces, and they cause our galaxy to stretch in gradual, sweeping motions. The outer disk of our galaxy has been distorted over millions of years by this stretching, giving its spiral arms faint ripples and waves. Some stars are pushed off course. Gas clouds move and drift. It's a gradual transformation of our house, nothing violent. The fact that galaxies can sense the tides of the cosmos serves as a reminder that no structure, no matter how big, exists in isolation. Everything flows in time and is interconnected. Galaxies can surpass our own size by more than 100 times. With hundreds of billions of stars and a width of over 100,000 light-years, the Milky Way is a vast galaxy. It's small, though, in comparison to the real giants of the universe. IC 1101 is one of the galaxies that spans more than 6 million light-years. That is over 100 times our own diameter. Clusters of galaxies are centered on these enormous ellipticals, and star formation wasn't the only way they grew so large. They have ingested dozens, if not hundreds, of smaller galaxies over billions of years. More stars, gas, and mass were added with each merger. Their old thick cores are teeming with aged crimson stars. Their outer regions, where lone stars spin in slow, huge circles, gradually fade into darkness. These massive galaxies are uncommon, silent, and challenging to understand. However, they serve as a reminder that even something as large as our galaxy is only middle-sized in the cosmos. Compared to the Milky Way, other galaxies are generating stars 1,000 times faster. The majority of galaxies slowly and steadily produce new stars. Perhaps 1 or 2 stars form in the Milky Way each year. However, starbursts, brief explosive bursts of star formation, occur in some galaxies. Dense clouds of gas that collapse under gravity give birth to hundreds or even thousands of new stars every year in a starburst galaxy. When two galaxies move across one another and stir up their gas, collisions or mergers frequently cause these outbursts. This causes the galaxy's core to suddenly light up with ultraviolet light, heated dust, glowing gas, and young stars. However, this rate is not sustainable. Starburst galaxies rapidly deplete their fuel, and many of them go silent when the gas is no longer present. Before dissolving into more subdued forms, they briefly and spectacularly shine like cosmic fireworks. However, they are among the brightest galaxies in the sky for a brief period of time. Andromeda's super-big black hole has twice our mass. A super-huge black hole, an area of space so dense and enormous that not even light can escape, resides at the center of almost every giant galaxy. Located in the tranquil heart of the Milky Way, ours is known as Sagittarius, an asterisk. With around 4 million times the mass of the Sun, it is enormous. However, our closest massive neighbor, the Andromeda Galaxy, has a far larger black hole in its center. It has at least twice as much mass as we do, if not more. Both black holes are quite calm at the moment. They don't shine like quasars because they aren't actively eating matter. However, they might have blazed in the past. Additionally, the black holes of the Milky Way and Andromeda may spiral together and unite into a single, far more gigantic object when they merge in the future. One future black hole lurking in the shadows, 2 galaxies, and 2 hearts. Galaxies, as they were 13 billion years ago, are visible to us. Exploring deep space is like exploring the past. The light from the farthest galaxies that humans can see has been traveling through space for more than 13 billion years since light travels slowly. In telescopic photographs, these galaxies look like small smudges. They are ancient, red-shifted, and dim. We're viewing them not as they are now, but as they were a few 100 million years ago, when the cosmos was still young. They are tiny, disorganized, and teeming with dust and newborn stars. Gleaming with the brightness of the first star generations, some are in the early phases of development. The modern universe was shaped in part by these early galaxies. The cosmic dark ages came to an end. They created the galaxy cluster's seeds. At a time when the universe was still coming into its own, they were blazing bright. And their brightness has somehow found its way to us throughout all that time. Invisible stellar streams from galaxies that have been consumed encircle the Milky Way. It took time for our galaxy to form. As it gradually expanded, it merged with and devoured smaller galaxies, and every time it did, it left behind faint hints like quiet trails with slender streams of stars extending throughout space. These are star streams, which are the remains of long-gone galaxies that were ripped apart by the gravitational pull of the Milky Way. Though undetectable to the naked eye, they can be identified with close inspection as they loop and swirl around the galactic halo. Some, such as the remnants of the Sagittarius dwarf galaxy, which we are currently absorbing, are still largely intact. Some have become diffuse ribbons of old stars because they are so old. By mapping these streams, astronomers can discover the fingerprints of previous collisions and trace the history of the Milky Way. Events that occurred billions of years ago have sculpted the peaceful motion in the sky around us, and we are still floating through its echoes now. Andromeda and our galaxy will collide and become one. The Andromeda and Milky Way galaxies will collide in roughly 4 billion years, in a gradual gravitational dance that will take hundreds of millions of years to complete, rather than abruptly or violently. Andromeda is constantly approaching from our perspective. At about 100 kilometers per second, its velocity across space is pulling it toward our direction. The two galaxies will eventually cross each other. Their forms are disturbed by gravity, but their stars largely escape direct contact. Arms in a spiral will tangle, clouds of gas will clash. There will be new stars born. They will eventually find a new home together in a single, bigger, elliptical galaxy. This future galaxy is sometimes referred to as Milky by astronomers. The merger might be transferred into another region of space, where our solar system might survive. It's a low-key drama that has already started and is unfolding at the speed of galaxies. It seems that some galaxies are composed of nearly pure gas. Stars are not found in every galaxy. Oddly, some appear to have virtually none at all. With few stars to illuminate them, these ethereal galaxies are primarily composed of cold hydrogen gas. Only the weak radio signals their hydrogen emits let us spot them as they drift around the universe like dark clouds. They are still not fully understood, and astronomers refer to them as dark galaxies. It's possible that these galaxies never produced stars. Alternatively, they can be ghastly relics from previous mergers or collisions. In certain instances, they could be galaxies where star production was stopped before it started. They symbolize a peculiar stage of cosmic life, a sort of unseen potential, regardless of the reason. They have motion, mass, and structure, but they are almost invisible without stars, just chilly clouds drifting in between galaxies, awaiting an ignition, waiting to transform into what they nearly were. Only by warping light from behind them have we discovered entire galaxies. Not all galaxies use light to announce themselves. Gravity makes them visible. The light from that background object may be bent and distorted by the gravity of a huge galaxy that sits between us and something even farther away. One of the most potent instruments in astronomy is this phenomenon, which is known as gravitational lensing. A far-off galaxy's light can occasionally be distorted into arcs, rings, or mirror images. Additionally, even though the lensing galaxy is too faint or dirty to be detected otherwise, we are able to identify it in the process. Dark matter is abundant in several of these lensing galaxies. Others are simply sitting quietly at the appropriate moment. The universe behind them is magnified as they transform into natural telescopes. Additionally, we may learn about both galaxies by examining the light they bend, the one far behind it and the one doing the lensing. Jets of matter can travel millions of light-years when ejected from galaxies. Superlarge black holes are found at the core of many galaxies. These black holes can occasionally release strong energy jets as they feed by drawing in gas and dust. These jets originate from the swirling disk of material surrounding the black hole, rather than from inside it. Twin beams of particles are launched from the galaxy's core at almost the speed of light as a result of the energy being twisted and focused by magnetic fields. These jets are far longer than the galaxy itself, extending for millions of light-years. They appear as enormous blazing threads piercing the cosmos in radio pictures. Over great distances, the heat surrounding gas shapes galaxy clusters and affects star formation. These jets create some of the universe's largest known structures. And from something smaller than a solar system, they all start. The dark is illuminated by a tiny, bright spot where matter and gravity collide. Only a few 100 million years after the Big Bang, the oldest galaxy in existence came into being. It was black in the early universe. The first galaxies formed hundreds of millions of years after the Big Bang. Small formations where stars were formed by the cooling and condensation of gas. There were short-lived, clumpy, and chaotic galaxies among them, Amazingly, some survived. As of right now, the oldest galaxy we have discovered is only 320 million years old. Its light has been on its way to us for over 13 billion years. It's little, packed with up-and-coming stars, and surprisingly well-developed already. Astronomers can better comprehend the universe's early stages of galaxy formation by seeing it. It is not yet plainly visible to us. It is far away, red-shifted, and dim. However, we are able to gaze farther and deeper into time with every new telescope, and the tale of all that came after is carried by the galaxies that we discover at the edge of our field of view. Stars from other galaxies make up nearly all of some galaxies. Stars can occasionally be stripped away when galaxies collide or pass near one another, sweeping them into halos or dragging them into lengthy tidal tails. These stolen stars might add up over time. In certain instances, they even take over as the primary inhabitants of a brand new galaxy. The remnants of galactic interactions give rise to these, which are known as tidal dwarf galaxies. They don't start with a new collapse of gas from the early cosmos like most galaxies do. Rather, they are composed of stars that were formerly part of another entity. For a moment they sparkle with borrowed light like a collage of other galaxies' history, even though they may not have much dark matter and are brief on cosmic timescales. Despite coming from distinct surroundings, their stars now orbit one another under the influence of new gravity. Galaxies have the potential to be destroyed, yet occasionally they transform into something new. We discovered galaxies that appear to be revolving incorrectly. The majority of galaxies rotate in tandem with their surrounding gas. It's a natural outcome of their formation. The orientation of the stars that develop is determined by the rotation that clouds of matter undergo as they collapse due to gravity. However, other galaxies don't follow that pattern. The stars or gas inside them spin in the opposite direction from the direction of their disks. We call these galaxies counter-rotating. Mergers are typically the cause. It's possible that the incoming material had its own velocity and the galaxy ingested another one. The two motions do not align, they stay separate. Sometimes only the middle part spins backward. The whole disk is involved in others. These galaxies are uncommon and prominent on galactic motion maps. They serve as silent proof that an unexpected event occurred a long time ago. A temporal twist captured in the stars. Thousands of globular star clusters can be found in a single galaxy. Some of the oldest star clusters in the universe are globular clusters, which are dense spherical collections of stars. With hundreds of thousands of stars each, they orbit galaxies like small satellites. There are about 150 of them in the Milky Way. However, some galaxies have thousands, particularly massive ellipticals, large swarms of clusters that extend well beyond their apparent borders may encircle these galaxies. Every cluster is a remnant of the galaxy's early history or from galaxies it has absorbed. They preserve the chemistry, motion, and age of old stars, acting as sort of memory keepers. It's possible that certain clusters formed in the early phases of galactic construction, even before the galaxy they circle. Astronomers can learn about the formation, merger, and evolution of galaxies by counting and analyzing them. Despite their little appearance, these companions, which circle silently far out in the galaxy halo, hold tales that date back billions of years. Black holes that flash like beacons fuel certain galaxies. The black holes at the centers of some galaxies are noisy. Rather, when they actively feed, they draw in dust and gas, which swirl into a disk and heat up as they descend. An active galactic nucleus, or one that can glow brighter than the galaxy's stars put together, is the end consequence. These lights aren't stable, though. On time scales of years, days, or even hours, some AGNs fade, flare, and flicker. Changes in the flow of matter into the black hole are the cause of the flashing. The flow can get faster at times. It pauses occasionally. In rare circumstances, we've even observed galaxies change from active to quiet and back again. It's like observing a lighthouse blink in the distance across the vast expanse of space. It also serves as a reminder that, despite their frequent invisibility, black holes have the potential to become some of the universe's brightest things. At least for a time. The spiral arms of the Milky Way may be transient structures. The Milky Way and other spiral galaxies appear to contain sweeping spirals of gas, dust, and stars that resemble eternal arms. Those arms, however, may not be fixed. Instead of being structures, they might be patterns, such as traffic jams that pass through stars rather than automobiles. Density wave theory is the name given to this concept. It implies that when stars orbit the galactic center, they occasionally group together in areas known as spiral arms. Like automobiles slowing down and speeding up on a freeway, stars flow in and out of the arms. The substance inside the spiral varies, but the shape remains the same. Other hypotheses propose the arms might grow and dissipate over time, affected by gravitational interactions, star formation, or even historical collisions. Either way, the Milky Way's spiral arms are not static sculptures. As stars pass through them like currents in a huge cosmic sea, they are dynamic patterns that are always altering and shifting. Like moons orbiting planets, dwarf galaxies can also circle larger ones. There are others in the Milky Way. It's orbited by a set of far smaller galaxies, dwarf galaxies, each having only a few million to a few billion stars. These galaxies orbit slowly over billions of years and are gravitationally connected to us. Some can be seen in the night sky, such as the Big and Little Melanic clouds. Others were only recently found because they are so faint. A few of them might be the remains of more massive galaxies that were shattered. Some might be remnants of the early stages of galaxy formation, known as primordials. The development of larger galaxies depends heavily on dwarf galaxies. They may finally be drawn in, stripped of gas and stars, and combined with the host. But until that happens, they orbit quietly, traveling in long arcs through the cosmic halo. They are tiny companions, ancient travelers traversing a greater narrative, much like the moons that orbit planets. There are galaxies so faint they're practically hard to spot. Most galaxies are easy to miss without a telescope, but even with one, some are almost unnoticeable. These galaxies are so dispersed and faint that it is difficult to tell their stars apart from the surrounding space, even though some of them are as big as the Milky Way. They only have a small percentage of its stars. They're ghost-like, with very low surface brightness, typically appearing as pale smudges, even in deep sky surveys. Only in the last few decades have astronomers begun to discover them, employing sophisticated methods to pick up their faint glow. The origins of these are still up for debate. Some might be failed galaxies, ones that lost their gas before they could generate many stars. Gravity might have ripped others apart. Whatever their tale, they are vast and hardly perceptible, floating across the cosmos in almost complete quiet. We might have been blind to the innumerable others that are out there. Galaxies with a dying breath of light. Entire galaxies can be pushed out of clusters like cosmic runaways. Gravity can produce bizarre and violent effects in large clusters of galaxies. Galaxies tug on one another, occasionally passing near enough to exchange stars, gas, or momentum. Sometimes these exchanges go farther. At amazing speeds, one galaxy can be thrown completely out of the cluster and into intergalactic space. We refer to these as runaway galaxies. Interactions with ultra-large black holes expelled some of them. During numerous clashes, others were slingshotted. After being expelled, they become lone travelers who spend millions of light years cruising the void without any companions. Some leave behind lengthy stories about stars and gas. Only their core, isolated, silent islands in the dark are carried by others. Although they are difficult to locate, we have seen a number of these runaways. Each one relates a tale of upheaval and intensely personal interactions gone awry. Even galaxies can be sent into exile in a gravity-governed cosmos. The heart of the Milky Way may previously have been as luminous as a quasar. Our galaxy's center is silent and dark now, but it wasn't always like that. There is evidence to imply that Sagittarius A, the superenormous black hole at the center of the Milky Way, may have previously experienced an active phase. It might have consumed a lot of gas at that time, igniting the galactic center like a quasar. There are still traces of the activity. We find gigantic bubbles of gamma rays, the Fermi bubbles reaching above and below the plane of the galaxy, probably pushed out by prior eruptions. X-ray flare echoes that bounce off clouds close to the core are also picked up by us. The memory is still there, inscribed in radiation, even if it may have occurred millions of years ago, long before humans existed. It's possible that the Milky Way was once one of the brightest galaxies in the sky when the heart of our serene spiral flared. The cosmic web's hidden map is followed by galaxies. The universe contains structure on the biggest scales. It is patterned rather than random. Not all galaxies are dispersed equally throughout space. The cosmic web is the name given to the network they generate when they assemble along enormous filaments. The dark matter, gas, and galaxies that make up these filaments are connected over hundreds of millions of light years. There are vast, empty spaces between them, where hardly anything is present. Like towns lining invisible highways, galaxies originate and travel along these filaments. Tiny variations in the early universe, magnified by gravity over billions of years, produced the structure of the web. We've used galaxy surveys to map some of it, and computer models allow us to see its shape. However, the majority of the web remains unseen, particularly the dark matter that makes it up. Within this paradigm, galaxies develop and grow at the intersection of the filaments. The cosmos is interconnected in addition to being enormous. Super big black holes that are off-center can be found in some galaxies. The heaviest object in a galaxy should be located at the center, as one might anticipate. And that's typically the case. Galaxies' centers are often anchored by superhuge black holes, although this isn't always the case. We discovered galaxies that float tens of thousands of light years from the galactic core and have an offset black hole. It's possible that a collision kicked these dislocated giants. When two black holes combine, the new black hole may be launched like a cosmic cannonball due to the unequal discharge of gravitational waves. In some cases, a merger may leave two black holes in orbit around one another, one of which may be slightly off-center. Although they travel through their host galaxies like covert passengers, these off-center black holes still have an impact on their environment. It's difficult to find them. We can identify them by their odd movements, gas distortions or bright emissions in the vicinity. They serve as a reminder that galaxy centers are subject to change. The expanding universe causes light from far-off galaxies to be stretched into infrared. The speed of light in the cosmos is constant. However, the environment it passes through is dynamic. It's growing. The light itself is stretched by this expansion, which lengthens its wavelength and moves it closer to the red end of the spectrum. The change is so drastic for the farthest galaxies that by the time their visible light reaches us, it is infrared. One of the primary methods by which we gauge distance in cosmology is this process, which is known as redshift. The more distant a galaxy is, the more stretched its light is. The expanding fabric of space has dimmed and discolored the ancient starlight of some of the oldest galaxies ever seen, making them only visible in the infrared spectrum. To view them, we employ specialized telescopes such as the James Webb Space Telescope. Even after almost 13 billion years, these galaxies continue to glow. Their light has been altered, but not completely removed, by the universe itself. We discovered galaxies that continue to actively consume their neighbors. Not all galaxies collide, they eat. Over time, smaller galaxies are frequently drawn in by larger ones, which eventually absorb them completely after removing their gas and stars. Galactic cannibalism is the name given to this phenomenon, which continues to this day. We have observed galaxies in deep sky surveys with faint star trails behind them, remnants of smaller companions being ripped apart. Recent or ongoing mergers are indicated by these tidal features. There are several satellites in the process of falling into some galaxies. Others are apprehended while consuming a neighbor. Gravity distorted their formations. This is also happening in our own Milky Way, one by one, bringing in neighboring dwarf galaxies. Cannibalism is not an uncommon occurrence. It is a typical aspect of galactic expansion. Galaxies have a long lifespan, but they are constantly evolving and changing. And occasionally, they develop by absorbing everything in their environment. In optical light, some galaxies are invisible due to their extreme dustiness. We are not always reached by starlight. In certain galaxies, entire structures are obscured from view by dense clouds of dust that absorb visible light. These dust-rich galaxies frequently produce and recycle dust while forming stars at high rates. They may appear completely dark, dim, or invisible to the unaided eye or even through ordinary telescopes. However, they light brightly when astronomers view them at infrared or sub-millimeter wavelengths. Hidden galaxies can be seen in thermal light because dust absorbs short wavelengths and emits them as heat. Some of the most active star-producing galaxies in the early cosmos were discovered this way. We might not have become aware of their existence if it weren't for infrared astronomy. Life abounds in these dusty galaxies, stars being born behind layers of carbon and silicates. They have a faint but noticeable glow. Additionally, we can see entire galaxies form through the dust with the correct tools. Intergalactic winds have the ability to remove gas from clusters of galaxies. Galaxies in clusters are not voids. The intracluster medium, a thin hot plasma, fills them, and galaxies passing through it may feel pressure similar to that of wind. As a galaxy moves, this wind may push against its interior gas, removing it. Remarkably effective, the procedure is known as REM pressure stripping. High-speed galaxies can lose gas in spectacular tails that extend for tens of thousands of light years as they collapse into a cluster. They are no longer able to create new stars after being stripped. They also eventually fade into passive, silent systems. With long spectral hydrogen trails behind them, we have seen these stripped galaxies up close. It serves as a reminder that galaxies are influenced by their surroundings, in addition to collisions and mergers. Galaxies can encounter imperceptible opposition even in the vacuum of space, and occasionally they lose aspects of themselves in the process. Some galaxies emit X-rays when hot gas collides with them. Galaxies emit more than just unseen light. Sometimes their brightest emissions originate from an unseen source. Collisions of hot gas at millions of degrees. When individual galaxies interact and the gas between them becomes squeezed and heated, this frequently occurs in galaxy clusters. The consequence is a glow in X-rays visible by space-based observatories. Galactic cores, where black holes heat surrounding material to extremely high temperatures, are some of the universe's brightest X-ray sources. Others are outflows from intense star formation or shock fronts between colliding galaxies. What we cannot directly see is revealed by these X-ray glows. Silently, temperatures, pressures, and violent interactions occur. The galaxies themselves may look tranquil from afar, yet inside and between them there can be chaos, activity, and light far beyond human eyesight. It serves as a reminder that there is a much wider spectrum of light in the universe than what our eyes can detect. The way a galaxy bends light from behind it allows us to calculate its mass. Galaxies are enormous in weight as well as size. But because we can't place them on a scale, how do we know how much they weigh? Gravitational lensing is one effective technique. The light from that background object may be bent and distorted by the gravity of a huge galaxy that is situated between us and something farther away. The bend is stronger in galaxies with greater mass. Astronomers may determine the galaxy's overall mass, including the dark matter's invisible mass, by measuring the amount that the light curves. Arcs, rings, or even numerous pictures of background galaxies can be produced by some galaxies acting as natural lenses. Although slight, the effect is quantifiable. It enables us to weigh galaxies without having to view their entire composition. Even invisible components like dark matter leave fingerprints in the bending of light. In the quiet tug of gravity, we find the hidden structure of the cosmos. Some galaxies reach over 1 million light-years across. The Milky Way is already massive, but it isn't the largest sort of galaxy. Some giants, known as superhuge ellipticals, are far larger. The biggest of them, like IC1101, extends more than 1 million light-years from end to end. That's nearly 10 times wider than our galaxy. And they may contain almost 100 times as many stars. These huge galaxies normally lie at the heart of galaxy clusters, where they've expanded by consuming countless smaller galaxies over billions of years. They don't have a spiral structure. Instead, they're smooth, spherical, and diffuse, with stars spread out in all directions. As they get farther away, their light gradually dims and merges with the halo around them. A long history of collisions has fashioned them into ancient, huge, and subtly powerful entities. They observe the universe passing by while standing in the middle of a cluster, in the depths of space, silent beacons. The speed of our galaxy is over 600 kilometers per second. Though it may seem motionless, the Milky Way is not. We have a fast-moving galaxy. We're traveling through space at almost 600 kilometers per second, or more than 1 million miles per hour in comparison to the cosmic microwave background. The Milky Way's journey toward the Andromeda Galaxy, the solar system's orbit inside the galaxy, and the local group's drift toward the Great Attractor are all examples of this motion. Since everything around us is moving with us, we are not aware of this motion. However, we can quantify it by measuring minute changes in the cosmic background radiation and distant galaxies' velocities. Space is not a stage in and of itself. It is dynamic, and that motion includes us. We are always speeding through space on a trajectory molded by gravity, encircled by stars, and propelled by the universe's silent momentum. There are almost 50 galaxies in the local group. In the universe, the Milky Way is not alone. It belongs to the local group, a tiny galactic neighborhood, a group of around 50 galaxies that are gravitationally bound and dispersed over roughly 10 million light-years. The Milky Way and Andromeda are the largest members, with the Triangulum galaxy coming in second. The majority of the others are dwarf galaxies, which are tiny, dim systems that contain only a few million stars each. Like satellites, some orbit the larger ones. Others are able to move more freely in the outside areas of the group. Over time, these galaxies interact by exchanging stars, merging, and pulling on one another. The Laniakea supercluster is a considerably broader structure of which the local group is only one component. The local group, however, is our immediate cosmic family, a peaceful assembly of galaxies traveling through space together, each with its own unique tale, even on that enormous scale, yet connected to the rest by coal strands that are invisible. Gravity. The Milky Way is not our group's largest galaxy. Andromeda is it. Although the Milky Way is large, it is not the largest object in our locality. The Andromeda galaxy, a spiral galaxy more than 2 million light-years away and about twice as large as our own, is the rightful owner of that distinction. Although it has a center bulge and sweeping arms, it is similar in shape, but has a larger black hole, more stars, and a wider halo. The two main members of the local group, Andromeda and the Milky Way, are headed toward a gradual collision. Andromeda is currently moving toward us at a speed of about 110 kilometers per second. In a few billion years, the two galaxies will combine to form a bigger elliptical galaxy. Andromeda is a massive, complex system consisting of stars, planets, and mysteries, despite seeming like a faint fuzz in the night sky. It is our galactic twin in many respects, and it will eventually be included in the future of our galaxy. Halos of invisible particles encircle some galaxies. Every big galaxy has a dark matter halo surrounding it that is invisible to the naked eye. It exerts gravity but does not emit, reflect, or absorb light. These halos wrap the galaxy in an imperceptible sphere of mass that stretches much beyond its visible stars. They were found by astronomers who measured the rotation of galaxies. Unless there is more mass keeping them in, stars close to the edges move more quickly than they should. Dark matter, an enigmatic type of substance that predominates in the cosmos by a ratio of more than 5:1, is that hidden mass. The halos are what keep galaxies together. They probably developed inside of them, pulled into shape by the force of an unknown force. We are aware that these halos exist even if we cannot see them. They aid in the formation of the cosmic web, cluster galaxies, and shape them. Things that we haven't yet seen firsthand hold the cosmos together. Two dwarf galaxies that circle the Milky Way are known as the Magellanic Clouds. You may have noticed two odd patches of light in the night sky if you live in the southern hemisphere. They are galaxies, not clouds. The Milky Way is surrounded by irregular dwarf galaxies known as the Large and Tiny Magellanic Clouds. From a cosmic perspective, they are both relatively close, about 160,000 and 200,000 light-years away, respectively. Millions of stars, clusters, and gas clouds can be found in both. The Tarantula Nebula, one of the most active star-forming regions in the area, is located within the massive Magellanic Cloud. These two galaxies may have been captured in the last few billion years, making them new to our galactic neighborhood. They engage with one another in addition to being friends. As they travel around the Milky Way, gravity is drawing gas and stars away from them in their intricate orbits. As of right now, they are still apart, dazzling and erratic, floating near. However, they might eventually be captivated and assimilated. Star trails are left in their wake by the clouds. Silent signs of the Magellanic Cloud's orbit around the Milky Way are left behind. The sky is covered in long, dim lines of stars and gas. As the Milky Way's gravity pulls on the smaller galaxies, material is stripped away, creating these trails. The most well-known of these is the Magellanic Stream, a slender band of hydrogen gas that extends for hundreds of thousands of light-years behind the two galaxies. Additionally, there exist stellar streams composed of individual stars that have been separated from their original location. Astronomers may track the Milky Way's gravitational field's form and learn about the interactions between galaxies over time with the aid of these trails. They resemble faint, disappearing footsteps that indicate a journey through outer space. These streams serve as a reminder that galactic orbits are complex, even though the Magellanic Clouds are now intact. Behind them, they leave behind long, drifting echoes. Massive amounts of dark matter bind galaxy clusters together. Hundreds or even thousands of galaxies can be found in clusters, all of which are held together by gravity. However, scientists found that the observable mass of the stars, gas, and dust was insufficient to support the cluster. The gravity has to be coming from somewhere else. Dark matter is that stuff. The majority of the mass of galaxy clusters is made up of dark matter, which is undetectable. In order to keep the cluster stable, it slows the velocity of the galaxies and holds them in place. Although we cannot clearly see it, we can sense its existence. A massive hidden mass is suggested by the motion of galaxies, the bending of light as it travels through the cluster, and the temperature of the intra-cluster gas. These clusters would disintegrate in the absence of dark matter. Rather, they have stayed united for billions of years, islands of light in a black ocean, locked together by an unknowable force of gravity. Thousands of galaxies can form superclusters. Galaxies form clusters. Clusters form when groups come together. And those clusters in turn are part of something even greater, superclusters. These are the largest known structures in the universe. Sprawling areas made up of thousands of galaxies bound together by gravity and influenced by the dark matter framework. They are hundreds of millions of light-years in length. Some have a wall-like form. Others are set up like webs or filaments. They are loose groups of galaxies traveling through space together rather than actual things. While some are expanding, others are collapsing inward. One of these superclusters includes the Milky Way, and you're not alone. We witness superclusters on top of superclusters that extend throughout the observable universe in all directions. Gravity operating on minute imbalances left over from the Big Bang molded these enormous formations over billions of years. They serve as borders between enormous cosmic regions and are not merely large. The Laniakea supercluster, where we are located, signifies immeasurable heaven. In 2014, the limits of our galactic neighborhood were redrawn by scientists. They discovered that the local group, the Milky Way, and other neighboring galaxy clusters are all members of Laniakea, a much bigger supercluster. The Hawaiian words Lani, which means heaven, and A'a, which means expansive or infinite, are the origins of the name. It's a good term for a structure that has more than 100,000 galaxies and is more than 500 million light-years across. The shape of Laniakea is not a sphere. Galaxies in this network of filaments are moving toward a central area known as the vast attractor via unseen lines of gravity. Much of our motion in the cosmos is guided by this gravitational well. Lania changed the way we think about where we live, not just in a galaxy or a group, but in an incredible supercluster. It serves as a reminder that even the huge Milky Way is a component of something bigger, more subdued, and subtly lovely. The universe is made up of filaments that galaxies align along. Galaxies do not appear to be dispersed randomly when their positions are mapped on the biggest scales. Rather, they create the cosmic web, a massive network of interconnected structures. Galaxies form along slender filaments of gas and dark matter that span hundreds of millions of light-years. These filaments weave a web with luminous nodes of galaxies at the intersections, joining clusters and superclusters. Huge gaps and areas almost devoid of galaxies can be found between the threads. This structure's shape was shaped over billions of years by gravity's pull, starting in the very beginning of the universe. Where matter congregates, galaxies develop, and they travel along these invisible threads like passengers on invisible highways. We perceive delicate, enormous patterns that extend much beyond our line of sight when we gaze out into space, in addition to stars and galaxies. Even in silence, the universe is structured. There are gaps between these filaments that are almost devoid of substance. There aren't many galaxies in the universe. Actually, it's nearly completely empty. Vast voids, enormous black areas with relatively little matter, lie between the cosmic web's huge filaments. Tens or even hundreds of millions of light-years separate some of them. These areas are mostly quiet. However, a few stray galaxies may pass through. The emptiest places we are aware of are these cosmic holes. Together, they spontaneously evolved as matter in the early cosmos, leaving behind dense regions. Astronomers can learn more about the nature of dark energy and the universe's expansion by studying voids. The voids characterize the cosmic web in a similar way to how galaxies do. They are more than just the gaps. They contribute to the overall form, dark, silent, and almost unaltered by the passage of time. Some galaxies are cosmic hermits in the emptiness, existing in total isolation. The majority of galaxies reside in clusters or groupings, encircled by neighbors and molded by their interactions. However, some galaxies are solitary. These are field galaxies, which are systems that float in space by themselves, separated from any filament or cluster. Some live deep within voids, while others are discovered on their edges. They develop more subtly and create stars at their own speed, since they have no neighboring galaxies to pull on or collide with. Their gas remains undisturbed, and their shapes are less likely to be affected. How these cosmic hermits came to be in such desolate locations is a mystery to us. It's possible that some were expelled from clusters in the past. Others might have originated in areas with low densities. They travel through space alone, regardless of where they came from. These lonesome galaxies serve as a reminder that loneliness persists even on the largest scale in a universe where everything is interconnected. We can see galaxies everywhere thanks to the Hubble Space Telescope. Nobody knew exactly what the Hubble Space Telescope would view when it was launched. Astronomers directed it toward an apparently empty area of the sky in the late 1990s, one devoid of known galaxies and bright stars. Nothing noteworthy. For days, they left it to observe. The results were astounding. A small dot of space containing thousands of galaxies. This evolved into the extremely deep field, and then the Hubble Deep Field. It demonstrated that galaxies can be found anywhere in space. There are multitudes that date back billions of years in every pinprick of the sky. Some were small and old, some big and intelligent. However, taken as a whole, they demonstrated the universe's depth and richness. Our perception of the universe was altered by the pictures. What had been empty was now filled with time, structure, and light. The more we search, the more we discover. Thousands of galaxies can be seen in a small area of the sky in the deepest photos yet captured. Take a particle of sand and hold it at arm's length. The Hubble Extremely Deep Field covers an area almost equal to that of the sky, and we observe almost 10,000 galaxies in that small area. Stars, planets, and history abound in each one. Some are bright and close. Others are faint smudges, old galaxies that have been visible to us for over 13 billion years. When viewed together, they provide insight into cosmic time, spanning from the earliest stages of galaxy creation to the present. The picture shows a cross-section of the universe and a multi-layered history, and it conveys a powerful message. There must be hundreds of billions of galaxies in the cosmos if a tiny region of sky can support that many of them. There is more to these rich visuals than just pictures. They serve as time machines that allow us to peek into the past while also serving as a reminder of how much more is out there. The early universe was more populated by quasars. Quasars are uncommon today. Quiet black holes can be found at the core of most massive galaxies, including our own. Quasars, however, were common in the early universe. The center black holes of young galaxies have an abundance of gas to consume. Many black holes expanded quickly during that time, burning for millions of years as quasars. When the universe was less than 1 billion years old, some of the brightest stars we have seen were present. The tiny, far-off points of light that previously illuminated large swaths of space are visible to us just as they were back then. Their intense radiation changed the structure of galaxies and stopped star formation in some areas of their environs. They eventually ran out of fuel and became dark. The remnants of once-burning cores are now silent galaxies. Quasars are the remnants of a younger, more brilliant universe that can still be seen across cosmic time. Within a few years, some galaxies transition from quasar to calm. It was long believed that quasars were stable, burning brightly for millions of years before gradually going out of style. However, in recent years, we have observed galaxies whose brightness fluctuates sharply. We refer to these as changing look quasars. A galaxy might have the energy of an active black hole one year, then it fades as though the cosmic volume was lowered. They appear to switch back again in certain situations. According to astronomers, this flashing occurs when the gas flowing into the black hole shifts. The inner disk may collapse, get blocked, or experience a rapid surge. It implies that black holes can be far more dynamic than previously believed, regardless of the reason. Not only can a galaxy's heart flare and wane on cosmic timescales, but also on human ones. And even something as big as a quasar can experience abrupt illumination and calm. It takes more than 10 billion years for quasar light to reach us. One of the farthest things we can see are quasars. Even before the Earth and the Milky Way had fully formed, their light started its journey. The majority of the quasars that we see now are located more than 10 billion light-years away. This indicates that their light has been reaching our telescopes after traversing an expanding cosmos for 10 billion years. What we see is how they were in the early days of the cosmos, not how they are now. Cosmic time has faded, discolored, and stretched that old light. However, the mark of tremendous energy is still present. An entire galaxy was once outshone by the radiation from a feeding black hole. Observing a quasar is similar to looking through a lengthy time and space tunnel. It links us to a more youthful cosmos and a type of brilliance that is no longer visible in our immediate surroundings. The furthest stars of galaxies can spin so quickly that they are hardly contained. Galaxies are more than just empty space. They rotate. Their stars revolve around the center, balanced by motion and drawn by gravity. However, that motion gets severe in some galaxies. They appear as though they might take off into space since their outer stars spin at such high rates. Gravity holds them in place, not only from the gas and stars, but also from an unseen dark matter halo. Actually, astronomers' initial suspicion that dark matter existed at all was sparked by these stars' unusual spin and faster than expected motion. The galaxies would disintegrate without it. Even though they spin at hundreds of kilometers per second, the invisible mass keeps them together. A silent balancing act is required. Perfect tension between mass and motion. The unseen arms that keep the stars in place get stronger as they move more quickly. Polar rings, or disks inside disks rotating at right angles, are a type of galaxy. Some galaxies are more intricate than others, but most rotate in a simple plane similar to a spinning disk. Two disks make up a polar ring galaxy. The main galaxy, and a ring of gas and stars that revolves at a nearly straight angle around its poles. When a galaxy passes through another and leaves behind material that falls into a different orbit, these patterns most likely arise during galactic interactions. Gravity gradually forms that substance into a flat, rotating ring. As a result, one galaxy is wearing another like a halo, creating a stunning, uncommon phenomenon. Astronomers can better understand how galaxies merge and the form of dark matter halos by studying polar ring galaxies. Like layered currents in outer space, the two rotating systems travel independently. Additionally, they resemble cosmic wheels rotating on two axes when viewed from a distance. Stable, elegant, yet rather eccentric. Some galaxies have the shape of enormous cosmic donuts. Not every galaxy is elliptical or spiral in shape. Some have ring galaxies or central holes in which the majority of the stars circle an empty core. These are frequently created by collisions. The gravitational disruption caused by a smaller galaxy punching through a larger one can cause waves to ripple outward, compressing gas into a ring and causing the birth of new stars. The end effect is a donut-shaped galaxy. With little to nothing in the middle, it is bright on the borders. The symmetry of certain ring galaxies is flawless. Others show the violence that formed them by being distorted or off-center. They are uncommon but distinct. These galaxies, in contrast to spirals, exhibit unmistakable signs of a dramatic history. They are stable nonetheless in spite of their peculiar shapes, balancing the rotation of stars. A collision that may have occurred a billion years ago is traced by light. Instead of spiraling, stars in elliptical galaxies travel in random orbits. Spirals and elliptical galaxies are not the same thing. They lack flat planes, arms, and disks. Rather, they are diffuse, spherical clouds of stars, and motion is more chaotic inside them. Not every star orbits in the same path. Rather, they follow haphazard routes, with some traveling in circles and others in extended ovals, devoid of any kind of general pattern. The formation of ellipticals is the source of this randomness. Many are the result of mergers between galaxies. When two or more galaxies collide, their star's ordered motion is upset. The system eventually takes on a more spherical form, although it still lacks a particular spin direction. These galaxies frequently have lower gas and star formation and are older. Like a serene mist, the light is even and smooth. However, each star moves in its own unique manner within a silent whirlwind of motion kept together by gravity. Certain atypical galaxies resemble ripped clouds of light. Not all galaxies are neatly elliptical or spiral. Some appear disorganized, extended, dispersed, and irregular. These are atypical galaxies that frequently resemble ripped clouds that softly shine across the stars. Many were created following previous collisions or near misses with more massive galaxies. Any organized structure they might have had was broken by the pull of gravity. Others formed as dispersed clusters of gas and stars, but they never established a strong central shape. They frequently include a lot of young, blazing stars and hydrogen. They may appear to be fragments of something bigger from a distance, yet they are galaxies in their own right, small, chaotic, and teeming with activity. Some are currently developing. Others might eventually settle into new forms or be drawn into larger galaxies. For the time being, however, they float as bright pieces that are more turbulence than symmetry shaped. In a cosmic flash, starburst galaxies burn away their fuel. Stars in the majority of galaxies form gradually over billions of years. However, that process is significantly accelerated in starburst galaxies. These galaxies produce stars hundreds or even thousands of times more quickly than they typically do. A merger, a close flyby, or a shock wave may cause the explosion. Anything that creates dense clouds by compressing gas. Rapid star formation at the start of the burst illuminates the galaxy with ultraviolet and infrared radiation. Although these galaxies are brilliant, the phase is short-lived. The gas is depleted, and the galaxy settles down in a few million years, a little span of cosmic time. What remains is a lingering glow of hot dust, a surge of new stars, and a flare of brightness. Starbursts are fierce, gorgeous, and fleeting, much like cosmic firestorms. They serve as a reminder that, like stars, galaxies can experience bursts of brightness, followed by periods of stillness. When galaxies lose the gas necessary for star formation, they may become quiet. Galaxies need gas to make new stars. When the gas runs out or is stripped away, star formation slows and eventually stops. The galaxy goes quiet. As stars burn through the gas over billions of years, this can occur naturally. However, external factors may also be the culprit. The gas in a galaxy may be lost to the surrounding medium if it falls into a cluster. The gas can be expelled by a wave of feedback from huge stars or powerful radiation from a black hole. The galaxy goes into a quiescent phase at that point. Older, redder stars replace its dying, youthful blue ones. The galaxy continues to light, but it does so more subtly now. It is wandering rather than producing. Some people refer to these galaxies as red and dead. They aren't exactly dead, though. They are the silent ancestors of the universe, bright remnants of a more vibrant era. Matter can be blown into intergalactic space by galactic winds. The process of star formation is not gentle. Winds are strong fluxes of particles and energy produced when numerous stars form at once, and they have the ability to force gas out of a galaxy. The effect is enhanced by supernova explosions, which heat the gas and push it outward. These cosmic winds can occasionally be powerful enough to carry material into intergalactic space, well beyond the galaxy's borders. This essentially stops future star formation by removing the raw material. Galaxies containing active black holes and starbursts have particularly intense galactic winds. By controlling the rate of growth, they influence how galaxies evolve. These winds have been seen by us as hot gas clouds that glow as they rush out from galactic centers. They alter the galaxy's future, but they don't stop it from shining. Millions of unborn stars can be impacted by a single windstorm, a breath that transforms everything. Black hole radiation can prevent galaxies from producing new stars. Instead of simply glowing, an extremely large black hole pushes back when it consumes gas and particles. Gas in the vicinity may be heated by the released energy or may possibly be blown out of the galaxy. Galactic evolution is significantly influenced by this mechanism, which is called active galactic nucleus feedback. Gas cannot collapse to create new stars if it is too hot. Furthermore, the galaxy will have little material left over if it is evacuated. In this sense, the entire rate of star creation can be regulated by a single black hole, which is invisible and small in relation to the galaxy. This feedback probably caused some of the biggest galaxies to cease producing stars billions of years ago. The scorching halos and empty cores they left behind are still remnants of their active pasts. A galaxy's center may be silent, yet it has the power to alter everything in its vicinity. The hydrogen gas that surrounds galaxies allows us to identify them. In visible light, not every galaxy is brilliant. However, clouds of hydrogen, the most prevalent element in the cosmos, envelop numerous. The 21-centimeter line is a weak radio signal that this hydrogen emits. Astronomers can use optical telescopes to detect galaxies that are ordinarily too faint or hazy by tuning into that frequency. These signals provide information about the mass, rotation, and motion of galaxies in space. Since hydrogen obeys the gravitational attraction of invisible mass, they also aid in the calculation of dark matter. Some sky surveys create maps of hydrogen over cosmic time by focusing just on radio waves. In this manner, galaxies that are unseen by the naked eye but subtly shining at radio frequencies can be found. Echoes are left by even the tiniest galaxies. There is something to hear, even when there is no sound. In radio waves, certain galaxies have a strong glow. Galaxies are typically thought of as being illuminated by visible light. However, radio waves, a type of light with far longer wavelengths, are strongly emitted by numerous galaxies. Super-large black holes generate the enormous jets of particles that shoot out from the nuclei of some of the brightest radio galaxies. Sometimes extending for millions of light-years, these jets extend well beyond the galaxy's observable border. Supernova explosions or clouds of cold hydrogen gas are the causes of other galaxies' radio glow. Radio galaxies can have odd shapes, such as twin sources of light, arcs, or lobes. When viewed on radio maps, many of these features, which are invisible to the naked eye, appear plainly. Astronomers can investigate hidden structures, track energetic processes, and examine how galaxies interact with their environment by using this kind of galaxy observation. The universe appears completely different and full of silent power in the radio sky. Only far infrared light can reveal others. Dust and dense clouds obscure some galaxies, allowing infrared light to pass through while blocking visible light. These galaxies, also known as infrared bright galaxies, frequently produce stars quickly. Nearby dust is heated by the young blazing stars, giving it a dazzling far infrared glow. Regular telescopes cannot view these galaxies, but infrared observatories can see them clearly. Before space telescopes like Spitzer and Herschel opened the new window into the sky, some of the universe's most active galaxies were virtually invisible. We can see through dust and discover what's going on inside by using infrared observation. The formation of stars, black hole feeding, and merger dynamics. It serves as a reminder that galaxies are not always visible. Some conceal themselves behind self-made veils, softly glowing in wavelengths that are invisible to the naked eye and only visible to those who know where and how to look. Early universe galaxies appear more disordered and smaller. Galaxies from the early cosmos, whose light has been traveling for more than 10 billion years, do not resemble the majestic spirals and smooth ellipses that we see in our immediate surroundings. They are more disorganized, lumpier and smaller. Some are still forming clusters of gas and stars. Others are producing stars, colliding or merging at amazing speeds. These early galaxies are still putting themselves together. They still haven't settled into shape. Their stars are more metal-poor, younger and hotter. Nevertheless, these galaxies established the groundwork for the contemporary universe. They expanded throughout billions of years by settling into more stable structures, producing new stars and combining with other stars. We are observing the adolescence of the universe as we look at them today, messy, energetic, and imperfect. Galaxies are still figuring things out. The cosmic daybreak is visible to us. The universe was originally illuminated by galaxies. The universe was entirely dark at one point after the Big Bang. Just cooling gas, no galaxies or stars. The first light then gradually came on. The first stars appeared. The earliest galaxies formed. We refer to this time as the cosmic dawn. Additionally, it started between 200 and 400 million years after the Big Bang. We are now starting to peer into that age with the help of powerful telescopes like the James Webb Space Telescope, which is able to capture dim, faraway galaxies from the early light of the universe. These galaxies are very brilliant for their size, small and chaotic. The cosmic dark ages came to an end as they quickly produced stars, burned through gas, and started ionizing the nearby hydrogen. Every picture we take during this period offers a window into the early stages of the universe's development, including its initial attempts at light and structure. Even though it's a far-off tale, it's the origin of all we know. It's possible that dark matter halos are where the first galaxies formed. The distribution of matter was not uniform in the early universe. Under the influence of gravity, tiny density variations that had been sparked by Big Bang quantum noise started to expand. Dark matter accumulated into halos, which are imperceptible clouds of mass that served as the gravitational wells required to collect normal matter, where those fluctuations were greatest. The earliest stars and galaxies were created when gas cooled, condensed, and formed inside those halos. These galaxies probably couldn't have formed at all if dark matter hadn't been present. In the early environment, the halos provide protection, bulk, and structure. This trend is still evident today. From massive spirals to tiny dwarfs, every galaxy we see appears to be encased in a dark matter halo. It's an unseen framework influencing the growth and motion of galaxies. Not all the early galaxies were fortunate. They were held in invisible hands. In the absence of dark matter, galaxies would just disintegrate. Galaxies rotate. Their stars travel fast around the center. However, something didn't add up when astronomers attempted to determine how much apparent mass was required to hold those stars in place. The galaxies ought to have separated. The stars were traveling too quickly to be held in place by gravity alone. The concept of dark matter then surfaced, an unseen type of material that permeates the galaxy and provides the additional gravitational pull that holds everything together. Although we cannot immediately see it, its effects are evident. Galaxies wouldn't maintain their shape without it. Stars would float into space from the borders. The whole thing would fall apart or disperse. Galaxies are held together in reality as well as in theory by dark matter. It's silent, enigmatic, and vitally necessary. Stars are what make galaxies glow, but we still don't fully understand why they remain together. Compared to the stars in the Milky Way's disk, the stars in its halo are far older. There are various components to the Milky Way. A broad diffuse halo, a flat rotating disk, and a central bulge. Some of our galaxy's oldest stars are found in that halo. These stars travel in long, looping orbits that carry them far above and below the disk, and many of them are very old. Several are over 10 billion years old. There aren't many new stars formed in the halo because of its low gas content. Its inhabitants are elderly, dull, and silent stellar relics. Since they formed before heavy elements were widely used, many of them are metal-poor. In contrast, the stars in the disk have more recent compositions and ordered trajectories and are younger and brighter. Astronomers may see into our galaxy's distant past, back when the Milky Way was still forming and before the spiral arms formed, by examining halo stars. Other galaxies gave birth to some of the Milky Way's stars. Our galaxy has not always included all of its stars. The Milky Way has collided with and absorbed numerous smaller galaxies over billions of years. When it did, some of their stars were retained. The weak streams, clusters, and sporadic stars that were left over from these early mergers currently travel across the Milky Way with peculiar orbits or chemical signatures. Their composition and velocity allow astronomers to identify them. Certain stars go in unexpected directions. Others are composed of simpler, older components. These stars provide information on extinct galaxies or systems whose stars continue to exist. There is more than one structure in the Milky Way, a silent compilation of tales drawn from the cosmic neighborhood. It is a multi-layered recollection. Furthermore, galaxies that are gradually merging with our own are still bringing in new stars. Mapping stellar streams allows us to track the motion of old mergers. A smaller galaxy is not absorbed by the Milky Way all at once. The arriving system's stars form lengthy curved trails or stellar streams that encircle the galaxy in ribbon-like fashion. For billions of years, these streams may persist before gradually diminishing and merging with the halo. Astronomers may reconstruct what happened, where the original galaxy originated, how it was torn apart, and when the merger took place by charting their positions and motions. Certain streams are wide and clearly defined, others are frayed and thin. When taken as a whole, they show a history of peaceful collisions that grew the Milky Way by gradually attracting its neighbors rather than through abrupt chaos. The eye cannot see these patterns. Once viewed, they change our perception of the galaxy and convert it into a map of ancient motion, but they also need meticulous measurements, extended exposures, and patient analysis. Galaxies are machines of time. We can see farther back the farther they are. Light travels slowly. As a result, we perceive a neighboring galaxy as it was a few million years ago. However, we are witnessing galaxies from the early cosmos when we gaze at them from billions of light years away. The farther back in time we look, the farther away. Galaxies become natural time machines as a result. Over the course of cosmic history, we can observe how they form, alter, and evolve. By gathering light that has taken eons to reach us, rather than by going through time ourselves. Every dim galaxy in a far-off image is a tale from long ago, and every telescope is a time gateway. Some are chaotic and young, others are fully developed already. Astronomers were able to put together the history of the cosmos by examining galaxies at various distances, from the earliest glimmer of light to the present-day sky's rich structure. The Milky Way rotates once every 200 million years. Our galaxy's stars are not fixed. They follow lengthy routes through space, each circling the center at its own speed. For instance, our solar system will complete a full circle of the galaxy in around 225 million years at a speed of about 220 kilometers per second. This indicates that since the formation of the Earth, we have only made roughly 20 orbits around the Milky Way. Whole centuries of life span a single galactic year since each orbit is so drawn out. During a single rotation, dinosaurs rose and plummeted. Continents move, stars are created, and then die. The sky appears to be motionless from our vantage point, but we are always on the move. We go through a silent spiral of stars while the galaxy rotates like a gigantic wheel. At this scale, time seems to stretch endlessly, and motion is only perceived between worlds. Unlike solid disks, galaxies do not spin. They move differently in their outer sections. Like the edge of a spinning record, the outlying stars of a galaxy would move more slowly than the ones closer to the center if it were a solid thing. Galaxies, however, are not solid. They are composed of dark matter, gas, and stars, all of which move according to gravity. What we observe is unexpected. The outer region stars orbit at the same speed as the inner region stars. Astronomers were perplexed by this smooth rotation curve until they understood that an unseen source of mass had to be at play. That something is dark matter stabilizing and encircling the galaxy in a halo. The stars at the edges would fade away without it. Galaxies rotate in intricate ways that resemble loosely connected systems held in place by invisible mass rather than hard wheels. Both what we can see and what we cannot set the deeper rhythm to which the stars dance. A motion equivalent to the collective rotation of hundreds of billions of suns. By observing the rotation of galaxies, we were able to uncover dark matter. Astronomer Vera Rubin investigated spiral galaxy rotation in the 1970s. Her expectations were not met by what she discovered. Outlying stars were traveling too fast, as though they were restrained by an unseen force. They ought to have drifted away in accordance with gravity. However, they didn't. The sole reason was that galaxies had significantly more mass than was visible to the naked eye. Dark matter is the term given to this invisible stuff. Although it doesn't release energy or light, it has enough gravitational pull to hold galaxies together and influence how they move over cosmic time. Today, dark matter's gravitational effects provide almost all of our knowledge. Although it is not directly visible to us, motion makes it visible. We discovered signs of something large and unseen in the curves of spinning galaxies. Something that may keep the cosmos together, and something that is still unknown. Galaxies we couldn't see in any other way have been made visible by gravitational lensing. Galaxies can occasionally be identified by their effects on other people's light, rather than by their own light. A cosmic lens is formed when the gravitational pull of a giant galaxy or cluster between us and a farther-off object bends the background light. Gravitational lensing is an effect that can make weak, distant galaxies visible that would otherwise be invisible. The image is stretched into arcs, rings, or mirrored replicas by the lens's magnification and distortion. Astronomers have used this method to find some of the most distant galaxies ever observed. Sometimes the bulk of a foreground lens brings into view galaxies whose light has traveled over 13 billion years. Lensing is not limited to revealing hidden galaxies. It also enables us to map the dark matter distribution. This bending of light turns gravity into a sort of telescope, and space itself becomes an instrument. Strong lenses. Some galaxies distort and magnify the light of nearby galaxies. Galaxies do more than simply orbit and emit light. Behind them, light from neighboring galaxies is bent by some that function as strong lenses. A single backdrop galaxy can appear as a ring or arc wrapped around the foreground lens, or as numerous pictures when the alignment is just right. Curved space produces these remarkable symmetrical Einstein rings. The lensing galaxy must have sufficient gravity to warp the light's course, regardless of its size. Angles, distance, and mass all affect the final image. The form that the backdrop galaxy's light assumes after bending around the lens is often all that is visible to us. These systems are uncommon and exquisite. They enable astronomers to examine the lensing galaxy itself, as well as its far-off source in a single image. We can observe how light moves through a curved rather than straight universe in these subtle distortions. Galaxies have the ability to magnify the far-off cosmos by acting as natural telescopes. In order to see farther, deeper, and more clearly, we construct telescopes to collect light. However, the gravitational pull of the natural world's telescopes, galaxies, and galaxy clusters bends and magnifies them as if they were behind them. By magnifying dim objects, these natural lenses enable us to view things that would otherwise be obscured by darkness. This method was used to find some of the most distant galaxies ever found. Huge foreground systems stretched and enhanced their light. Details that we couldn't otherwise resolve are revealed by these lenses. The velocity of gas, star formation, and the structure of early galaxies. They depict the cosmos not only as it is, but also as it was, enlarged over time. Light is subtly and elegantly bent by the universe. We get a glimpse of things that are well beyond the scope of our instruments through that bending. Galaxies that are observable due to gravity alone. Whole galaxies were discovered within gravitational arcs. Gravitational lensing can stretch the picture of a distant galaxy into an arc, a long curving ribbon of light that wraps around a foreground mass. In some circumstances, what looks like a single arc turns out to contain an entire galaxy magnified and warped by the lens. These arcs are more than lovely shapes. They are time capsules showing us galaxies as they were billions of years ago. Astronomers can measure the source galaxy's mass, composition, and star formation rate in addition to reconstructing its original shape and structure through meticulous modeling. Galaxies from a few 100 million years after the Big Bang can be seen in some arcs. Without lensing, we would never detect young systems. These arcs need precise alignment and are uncommon and fragile. However, they provide a window into the distant past. When we locate them, we discover far-off galaxies pulled out by gravity's hand in their curves. At almost the speed of light, galaxies close to the boundary of the observable universe are vanishing. As the universe expands, galaxies get farther away from us at a quicker rate. This is the stretching of space itself, not motion through it. Galaxies retreat at speeds that are close to the speed of light as a result of this expansion at sufficiently large distances. Galaxies are so far away from the end of the observable universe that by the time their light reaches us, it has been stretched into radio waves or extreme infrared. We might already be unable to reach some of them. Their light can no longer reach here across the growing space. Ancient light sent from a time when they were closer is what we see now. More galaxies will eventually pass over this cosmic horizon. In addition to being enormous, the universe is dynamic. Furthermore, the galaxies that are the furthest away are fading into silence, not because they are running, but rather because space is drawing them away. In defiance of the universe's expansion, some galaxies are rushing in the direction of one another. The majority of galaxies are drifting apart on a huge scale as the universe expands. Not all, though. The Milky Way and Andromeda are two galaxies that are getting closer. Gravity is still effective and can overcome cosmic expansion in areas where it is strong enough. Galaxies are drawn inward by reciprocal attraction within clusters and groups. In roughly 4 billion years, the Milky Way and Andromeda are predicted to collide. In addition, other galaxies are moving closer to one another, forming groups, pairings, and eventually mergers. Even though the universe is expanding, galaxies can still be held together by local gravity. We are reminded by these gestures that expansion isn't everything. Gravity continues to create its own niches, small areas where the rules seem different, and galaxies aren't exploding in those locations. In a cosmic ballet that takes place over billions of years, they are gently floating toward one another. Across hundreds of millions of light years, galaxies are connected by the cosmic web. The universe is not a random collection of galaxies on the biggest scale. It's structured. The cosmic web is the pattern created by galaxies congregating along lengthy strands of gas and dark matter. These filaments connect clusters and superclusters into a large network over great distances. Vapors, almost empty regions with few galaxies, lie between the filaments. Tiny ripples in the early universe's density, magnified by gravity over billions of years, formed the cosmic web. These strands are drawn to areas of higher density where galaxies form. Through galaxy surveys, we have mapped portions of this structure, and simulations show even more. It is a huge three-dimensional network composed of the gravity that holds stars in place rather than the stars themselves. Galaxies are social beings. They are a part of a far broader structure that spans the dark, expanding universe and is linked by invisible threads. There are galaxies that appear to be whirling uncontrollably. The majority of galaxies rotate in a systematic manner, with their stars following smooth, predictable orbits around the center. However, certain galaxies behave strangely. Their outer sections flare outward, twist, or distort. In others, the gas and stars are traveling in opposing directions. These galaxies frequently developed as a result of structurally disruptive mergers or near encounters with neighbors. For a while at least, the action inside of them becomes chaotic. Sometimes the galaxy as a whole is distorted like a pond's ripple. It's more like a broken wheel in others. These systems are studied by astronomers to learn how galaxies bounce back from collisions and how long it takes for chaos to give way to peace. As gas settles into new orbits and gravity reshapes galaxies, even the most bizarre ones eventually stabilize. But in the moment, they appear wild. Galaxies are still shaking from past events, slowly recovering their balance again. Galactic mergers can take billions of years to complete. A collision between two galaxies is not an abrupt crash. Over billions of years, this intricate and gradual interaction takes place. First, as gravity pulls them together, the galaxies get closer. Their gas and dust collide, squeezing and causing star formation bursts, but their stars mostly escape direct contact as they pass through one another. The galaxies may repeatedly swing past one another, their forms warped into loops and long tails. They eventually come to rely on one system. Their mass, speed, and angle all affect the outcome. Some develop into elliptical, smooth galaxies. Others still have traits from both parents. The new galaxy may not stabilize for hundreds of millions of years after merging. Clusters of stars are moved. As black holes move closer to one another, the galaxy gradually reaches a new balance. It's a dance rather than a crash. Beautiful, slow, changing everything. Black holes in galaxies may spiral and merge when they merge. A tremendously big black hole is located in the center of the majority of huge galaxies. Black holes from merging galaxies are pulled toward the center of the new system. They initially circle each other in a distant orbit, gradually losing energy when they come into contact with gas and stars. The distance gets smaller over time. They eventually go into a last spiral, getting closer and closer until they combine to form a single, larger black hole. This last phase is short and quite active. It causes disturbances in the fabric of space-time and gravitational waves. We're only now starting to see these waves, which have been prophesied for decades. A lengthy cosmic voyage comes to a conclusion with each black hole merger. After forming in different galaxies, two huge objects eventually united to form one. From a great distance, the event is silent, but it has a permanent impact on the universe's form. Some collisions result in smooth, featureless, elliptical galaxies. Structure, arms, disks, and dust lanes abound in spiral galaxies. However, the outcome is frequently quite different when two spirals combine. The new galaxy can become a smooth, elliptical blob of stars and lose all traces of its previous shape. Round or oval in shape, these elliptical galaxies have little gas and seldom any new star formation. Their stars cast a gentle, uniform glow as they travel in erratic orbits. The orderly spiral arm patterns are erased as the stars are mixed and their motion is jumbled by the chaos of the merging. Further star birth may be stopped by the gas being heated or ejected. As time passes, the cosmos becomes quieter. The cores of galaxy clusters where mergers are frequent are dominated by these elliptical galaxies. They are the universe's ancient giants, produced by numerous collisions, shining quietly and hardly showing the drama that shaped them. Tidal tails of stars spanning hundreds of light years are left behind by others. The stars of galaxies that pass near one another are stretched by gravity, creating long, delicate arcs of light rather than being forcefully thrown out. We refer to these as tidal tails. They can extend well beyond the boundaries of the initial galaxy, spanning hundreds of thousands of light years. During an encounter or merger, the opposing pull of gravity creates them, and they frequently curve outward like silky strands, glowing dimly with pockets of gas and scattered stars. While some tails linger through space for billions of years, others eventually return. These trails, which are graceful and slow and were formed by motion rather than impact, are silent witnesses to historic collisions. There is even enough material in some tidal tails to create new, smaller galaxies. Others continue to exist as dim streams that shine like cosmic paintbrush strokes. We witness galaxies changing one another as they pass, preserving the memory of prior motion. Over time, many of the smaller galaxies have been absorbed by the Milky Way. In the past, our galaxy was not as big or organized as it is today. Billions of years. It expands by attracting and assimilating dwarf systems and smaller galaxies that have strayed too near. Observable remnants of some of these mergers include star streams, clusters with odd orbits, and chemical signatures that differ from those of our native population. Others have been completely broken down, and their stars are now traveling with ours. Every merger changed the halo's form, contributed mass, and altered the speed of already existing stars. These were gradual integrations, gravitational embraces that developed over millions of years, rather than spectacular collisions. By charting the motion and makeup of stars in the outer parts of the Milky Way, we are still able to identify some of these absorbed galaxies. Our galaxy is a layered structure, a composite of numerous smaller histories that have been wrapped into a single, peaceful spiral of light. We are continuously discovering new satellite galaxies orbiting the Milky Way. Satellite galaxies are a group of smaller, fainter galaxies that orbit the Milky Way. Only a handful, such as the Melanic Clouds, were recognized for decades. However, hundreds more have been found by astronomers in subsequent years. Many are so faint that they are almost imperceptible. Dark matter predominates in these extremely dim galaxies, which have only a few hundred or thousand stars. They are difficult to see because they are obscured by the Milky Way's own brilliance or lost in the sky's background. But they are significant. Each one advances our knowledge of dark matter behavior and galaxy formation. A few are traces of past mergers. The gravity of our galaxy is currently tearing others apart. These friends travel through the halo in long, leisurely circles about us in silence. We find more the more we search. There are many silent companions in the Milky Way's sky that we have only just started to observe. Massive star production in bigger hosts can be triggered by tiny dwarf galaxies. In the universe, size isn't everything. It can occasionally have a dramatic effect when a small galaxy passes close to a larger one. A dwarf galaxy can compress the gas and cause star formation bursts if it collides with or passes through the larger galaxy's gas-rich disk. Regions of the larger galaxy may be illuminated by these bursts, creating nebulae and clusters that outshine the smaller interloper. The results are dazzling and far-reaching, yet the process is silent and gravitational rather than explosive. This may be how some of the Milky Way's star-forming regions got their start. There is just enough disturbance from the dwarf galaxy to get things going. Similar to throwing a pebble into a still pond, a minor incident can have far-reaching effects. By just drifting close, even the tiniest galaxies have the ability to change their neighbors. There are compact groups of galaxies that are caught in a gravitational dance. Not all galaxies reside in peaceful seclusion or expansive groupings. Some people live in close quarters. A small number of galaxies are tightly related to one another and follow sluggish, looping orbits. There is a lot of contact in these small groups. The galaxies occasionally collide, churn up gas, and pull at each other's arms. They frequently have deformed forms. There are several with long tails. Others exchange dust and star bridges. Many of these galaxies will eventually combine to form a single, bigger system. They can continue to be different for billions of years, yet for now, they are caught in a silent dance. Since there isn't much space between them, gravity can constantly affect how they move. Despite their rarity and fragility, these clusters show how galaxies can grow in tandem. Finding galaxies so closely connected together, like a family of stars, moving as one is remarkable in the vastness of the cosmos. Clusters of galaxies can occasionally collide in a series of chain events. Interactions are common in big clusters of galaxies. They never change. There will always be collisions and close encounters when hundreds or thousands of galaxies pass through the same area. Occasionally, one merger leads to another. The shape of a galaxy may be altered by a collision with a neighbor, and the disorder may spread as it passes near another galaxy. These chain reactions have the power to release streams of stars into space, ignite star formation explosions, and stir up gas. The biggest clusters can function as cosmic mixing bowls, allowing galaxies to pass through them repeatedly while undergoing changes in speed, direction, and structure. Many eventually transform into smooth ellipticals as a result of numerous mergers. During the process, however, clusters are constantly moving, spanning millions of light years, a gentle, elegant turbulence. It serves as a reminder that galaxies are not solitary entities despite the immensity of space. Long, silent collisions cause them to jostle, merge, and change one another. Numerous old mergers may have produced the largest galaxies that we are aware of. There are galaxies that grow slowly. Others, like the brightest cluster galaxies, develop as a result of several collisions over time. These giants can have masses hundreds of times greater than the Milky Way and are frequently located at the core of enormous galaxy clusters. They did not form simultaneously. Rather, they expanded by successive mergers, attracting smaller galaxies over billions of years. Each contributed structure, stars, and mass. Any remnants of the individual galaxies gradually disappeared, leaving behind a huge bright cloud of stars. With satellite galaxies still being pulled inward, some of these giants now peacefully sit at the center of their clusters. They are monuments to the cosmos, the product of silent eating for ages. In their light, we perceive the culmination of numerous histories piled across time, creating a vast and tranquil entity. We discovered ghost galaxies moving between groups of galaxies. Some galaxies are discovered in the immense voids between, slowly floating through the void, while the majority reside in clusters or along cosmic filaments. These so-called ghost galaxies are hazy, weak, and difficult to detect. They might have been hurled out into the silence between clusters during a violent encounter or merger. Others might have developed there, away from the typical cosmic web formations. Many have few stars and minimal gas, making them almost undetectable. Nevertheless, they continue to glide through intergalactic space in silence as they migrate, orbit, and change. We discovered them by faint star trails, the modest movements of surrounding matter, or their gravitational attraction. Space is not empty, as these galaxies provide as a reminder. A small glow, the light of a galaxy floating alone through the darkness, may still be visible in the most remote regions of the universe. Because their stars are so widely apart, some galaxies are almost invisible. Not every galaxy is bright. Some, referred to as hyper-diffused galaxies, are dispersed across regions the size of the Milky Way, yet they have as many stars as a dwarf galaxy. The galaxy seems to be a dim cloud due to the sparse distribution of its stars. They hardly stand out from a distance, like a smudge in the shadows. It's possible that these galaxies evolved in a different way, or that tidal forces tore them apart, leaving just the smallest remnants. Some have virtually no dark matter. Others appear to possess far more than anticipated. Their very presence casts doubt on our knowledge of how galaxies maintain their cohesiveness. They are easily missed, weak and faint. But they continue, and sometimes a narrative may be told with just that perseverance. There is something to say even in the most silent cosmos. Long stretches of stripped gas can be left behind by galaxies. Galaxies frequently lose material when they pass through dense settings, like clusters. The pressure of the hot plasma that fills the gaps between galaxies removes their gas. Ram pressure stripping is a technique that can extract lengthy tails of dust and hydrogen that follow a moving galaxy like a ship's wake. These trails, which shine in ultraviolet or radio wavelengths, can stretch for hundreds of thousands of light years. Some exhibit indications of star formation, with stars originating distant from the galaxy's nucleus in the middle of the tail. Others merely float, gradually cooling. The future of a galaxy can be altered by stripping. It can no longer create new stars without gas. The trails it leaves behind endure, beautiful symbols of movement and loss, extending across space like memory, even as it gradually fades into quiet. Some galaxies are extremely compact, having a high star density. Ultra-compact dwarfs are at the other end of the spectrum from diffuse galaxies. Stars are packed into tiny galaxies. Despite having millions or perhaps billions of stars, they can only be a few hundred light-years broad. Some might be the remains of more massive galaxies that were eroded by tidal pressures to their dense centers. Others might have formed in this manner from the beginning. The density of these galaxies is really high. Within a single light year, a star in an ultra-compact dwarf may have thousands of neighbors. They have a tight structure and strong light, but because they are so tiny and can be mistaken for star clusters, they are difficult to locate. Astronomers can better understand how structures endure in harsh settings and what occurs when galaxies collide by studying them. These are cosmic pressure spots, where stars shine with subdued intensity while crammed into the smallest conceivable area. Others float like cosmic fog because they are so dispersed. There are certain galaxies that hardly resemble galaxies at all. The galaxy resembles a pale fog floating through space because of how thinly spaced out its stars are. These faint, hazy galaxies are frequently encountered in clusters. Many have virtually little gas. Some might be the remains of more massive galaxies that were destroyed by gravity. Others may have started off as ghostly systems that never accumulated enough density to be luminous. They are nearly undetectable from a distance. However, their gentle light is seen by long exposures and careful imaging. The notion of what a galaxy should be is called into question by these galaxies. They lack structure, intelligence, and vitality. These star clusters are still gravitationally bonded, though. They travel, change, and endure. They float, silent and nearly forgotten, yet still a part of the grand narrative of the cosmos, like mist clinging to the boundaries of space. As the universe grows beyond our horizon, galaxies might eventually be the only thing visible to us. The expansion of the cosmos continues to accelerate. Galaxies that are far away will gradually fade away until we are unable to see their brightness. Only galaxies that are connected to our own, such as Andromeda and a few others, will eventually be visible. All other things will pass beyond our cosmic horizon. The galaxies aren't actually traveling through space. They are being carried away by the expansion of space itself. A future observer may look out and find nothing except a peaceful local cluster of stars in a few trillion years. They may think the cosmos is small and motionless. However, even if that light is becoming less visible, we now know that the cosmos is big, rich, and full of light. Galaxies are not limited to what we can currently perceive. They are the remaining remnants of a once visible universe. Drifting silently in the direction of stillness, we are witnessing the eternal movement of galaxies apart. Each night sky is a moment in time captured in a great expanse. The galaxies we see now, bright, far away, and rich in history, are all evaporating. They will become increasingly redshifted, fainter and ultimately indiscernible over billions of years. The current state of the universe is a glimpse into its past. However, that window is gradually closing. We are fortunate that the universe can still be read today. Even now, light from far-off galaxies continues to reach our telescopes, revealing details about their motion and creation. Galaxies will drift into isolation when the gap between them widens due to ongoing expansion. However, the remembrance of their radiance endures despite their separation. These days, every picture, spectrum, and map we create documents a changing sky. Additionally, every galaxy that recedes leaves a silent echo of its former location. The narrative of the universe's formation is told by galaxies. Galaxies are the foundation of cosmic evolution, having evolved from the initial little clouds of gas following the Big Bang to the massive structured systems we observe today. They demonstrate the organization of matter, the birth and death of stars, the growth of black holes, and the propagation of light through space. We may piece together the history of the cosmos by examining galaxies at various distances and, consequently, ages. Early galaxies were chaotic and rapidly forming stars. Subsequent ones became bigger, more stable, and more organized. In addition to gravity, time also shapes galaxies. They have the scars from every conversation, every flash of light, and every silence. Like living creatures, they develop, alter, and settle. We witness the universe's development from youth to maturity during that evolution. The sky is more than a flat surface. It is a lapse in time, and the brushstrokes are galaxies. Every galaxy reflects our potential and serves as a cosmic archive. Every galaxy contains a record of stars that have come and gone, collisions that have been endured, and black holes that have been fed and faded. The chemistry of old gas clouds is preserved by their stars. Their movements reveal previous exchanges. Long histories of development and gradual change are reflected in their shapes. Additionally, galaxies represent what is conceivable because they are formed by the same rules that control humans. Structure can be seen where spiral arms are present. We witness change where we witness starbursts. And we envision long, calm aging when we see quiet halos. Galaxies are significant in addition to being gorgeous. They serve as a reminder that everything is subject to change, that memories endure over time, and that light can continue to reverberate long after its source has vanished. A galaxy is ultimately both far away and familiar. It contains the past, molds the present, and gives us glimpses of unimaginable possibilities. I appreciate you being here, listening, pondering, and silently floating through the galaxies. We have traversed giants and spirals, mergers and halos, silent dwarfs and luminous arcs of old light. Every galaxy had a narrative to tell, a fragment of the cosmos encoded in its stars, whether it was a brilliant galaxy or one that hardly spoke. The sky is now once more silent. Even if the facts change, we never forget the sense of time passing, distance, and our smallness in the face of something bigger. So be patient with your flaws. Let the rhythm of stillness be the motion of galaxies. Tonight, there will be no more inquiries, no more findings, only room. Simply remain calm. Simply go to sleep. Additionally, you can watch the next video right now if you're still awake. But it's also quite acceptable if your eyes are already closing. From the stars, good night and have a nice dream.